everybody, and welcome to my informative speech. I will be explaining how internal combustion engines work in as simple as terms as I possibly can, using this two-stroke 50cc engine. The two-stroke part I'm going to explain later, and the 50cc part doesn't matter. So the fact of the matter is that engines are all around us every day. We use them for transportation, manufacturing, and for energy. According to Gerald Catton, in an article in 2010 from the Inventions Journal titled Thermodynamics of Internal Combustion Engines, Examples of Insights, the number of vehicles alone in the world is estimated at 1.2 billion, and by 2035, they're projected to be 2 billion. With engines being something that affects us on a daily basis, knowing about how they work shouldn't be so niche. In order to convey a simple explanation, I will break it down to the fuel system, the internal combustion, and the drivetrain. So to start, I'm going to go over the fuel system in just the simple, most essential way possible. So the fuel components comprise of multiple steps leading to combustion in the engine, which starts first at a gas tank, which most of you guys have probably seen before, just usually at a larger scale. And that fuel is going to feed into the carburetor, which is going to mix with air or oxygen, and then create a certain ratio to send to the engine. And depending on the engine, it will change. In most cars, they got rid of carburetors, and now they have fuel injection, which is just more complicated, computers with a lot of sensors. And then after that, it'll go to the throttle, which, because this is a bicycle engine, it looks like a motorcycle, it's a hand grip. And then based on how much throttle you give it, it changes the amount of oxygen and fuel that gets sent to the engine through the inlet, and then it'll change how fast it's going. I'll get to that later. So, in the Defense Science Journal in 2019, author Samuel Jensen wrote that fuel quantity injected at any moment directly indicates the torque produced by an engine at a given speed, which is exactly what I just said, and I'll explain exactly how that works in a second. But he said all this in an article titled Development of a Fuel Quantity Based Engine Control Unit Software Architecture. So the number, like I was saying about how fast the engine's going, that changes your speed, which is directly related to your RPM, or rotations per minute, which is the number of rotations the crankshaft makes per minute. And an engine like this, which will make about 5,000 RPMs, means 83 rotations of the crankshaft per minute, which is pretty fast. So next up, we have the first part of the actual engine, which is this lower chamber known as the crankcase. And inside the crankcase is the crankshaft, which I was saying rotates to make those RPMs, as well as air and fuel, which is sent over through the inlet from the carburetor. So after the fuel and air gets into the crank case, it then gets sent up into the combustion chamber, which is the next part, which is where all the fun stuff happens. But in 1999, Jeffrey Lockledge wrote that the viability of an engine is determined by whether a suitable crank is designed, in an article titled Defining the Engine Design Process in the Journal of Engineering Design. So the second part of the engine is combustion. So with the two-stroke engine, there's a two-stroke cylinder head where the action happens and the combustion occurs. So at the top of the engine, you have a spark plug, which gives it spark. And basically, the fuel and air from the crank case right here gets sent into the combustion chamber, and then a piston will compress the fuel and oxygen to a tight little space, and then the spark plug ignites it, which explodes it and sends the piston speeding back down, which will then rotate the crankshaft. And that's the first part of the two-stroke engine, the first stroke. The second stroke is the piston going back up, which then compresses the fuel and oxygen that went back into it, and then explodes it again. So it's just that first and second stroke, and then it creates the piston going up and down, which rotates the crankshaft, making those RPM. And in the meantime, after it gets exploded, all that heat and fumes have to go somewhere. So that's where the exhaust comes in, right here, makes it more quiet. It's better for emissions and has somewhere for all that heat to go. So speaking of the exhaust, interestingly, it was found by Ali Tusi in 2017 that a very large portion of fuel energy is wasted through exhaust gases in an article titled Exhaust Gas Heat Recovery Through Secondary Expansion Cylinders in the Journal of Thermal Science. So finally, the part that moves the vehicle. The drivetrain converts the motion of the engine to work or to the purpose of the engine, because not all engines are just for moving vehicles. So back to that piston. Piston moves the crankshaft, which makes the RPMs. And the more RPMs you're making, the more speed you're making, because the crankshaft moves, which moves this little sprocket here, which in this case, a bicycle engine, will be connected to a chain. It looks like a bicycle chain, but it's kind of different. Connects to that sprocket, and then to a larger sprocket, which is then connected to a wheel, and then it turns your wheel. And if this was a car, instead of having sprockets and chains, you'd have gears and a drive shaft. So now that you hopefully have some sort of understanding of how internal combustion engines work, it is time to wrap it up. In conclusion of my informational speech, you have learned about internal combustion engines and how they work by each aspect of the system being discussed. It is important to remember that combustion engines are still the main source of propulsion in the world, according to research by Dior Wojcicki in 2017, and an article titled Exhaust Emissions from Small Engines and Handheld Devices in the MATEC Web of Commissions. So, remember what you can from what I've told you, and hopefully the next time that you drive in a car, you can try to imagine what exactly is happening underneath the hood.